Wiens law is the peak wavelength of a black body's or continuous radiation curve is inversely proportional to the black body's surface temperature. So we have a black body. It is a hot, dense object. It could be a gas, a liquid, or a solid. For example, it could be a star. And we want to know what is the surface temperature of the star and the peak wavelength of that star. So we're looking for two things, the peak wavelength, and we're also looking for the surface temperature. So as we can see, the peak wavelength is in this equation, which is called Wiens law, as well as the surface temperature. Now the wavelength and the surface temperature are related by this constant 0.0029 meters Kelvin. So if you know the maximum wavelength, you can solve for surface temperature. Similarly, if you know the surface temperature, you can solve for the maximum wavelength. Usually, you should find the maximum wavelength and solve for the surface temperature. Let's go look at a black body spectrum or a continuous radiation curve, this is the example shown in the figure below. On the vertical axis is the intensity or how much, and on the horizontal axis is wavelength. Now what you want to do is you want to find the peak in this continuous spectrum. Notice how there's no breaks in the spectrum at all. You don't see any white areas anywhere. You just see a continuous rainbow of colors. You want to find the peak where the maximum intensity is, and then you want to drop a vertical line down at the average value, which in this case is around 525 nanometers. Now this is the maximum wavelength, meaning the peak wavelength in the curve. Now this value of 525 nanometers is what we would substitute into the Wiens law equation as the maximum wavelength, meaning the peak in the curve. So we can then solve for the surface temperature. Notice that peak wavelength and surface temperature are inversely related because they're equal to a constant. So if the wavelength increases to a longer wavelength, then the surface temperature has to go down. Similarly, if the wavelength decreases to a shorter wavelength, then the surface temperature goes up.